Well, hello there! Welcome back to the JSsifu channel where we talk about JavaScript and algorithms. So today is our day 2 for our recursion series. Okay? If you haven't checked out our first video on our recursion series, go ahead and check out the first video that we have. Oh, yeah. And today we are going to write a recursion function for multiplication. What? Yes, you have two numbers as a given input, and you are trying to get the product of the two numbers. Why would you use recursion, you ask? Because we can. So the requirement for this function is that you cannot use the multiplication operation on this function. So how would you do it? You can do it with recursion. Yeehaw! So look at what's our requirement here. So you're given two numbers, alright? Let's say we have 2 and 4 as our input. Then what you get from the result of the multiply function? You should get 2 times 4, which is equal to 8. Alright? That's what you should get. How about 0 and 3? You get 0 times 3 equal to 0. Duh. So what is the curveball? The curveball is that you cannot use the multiplication operation in JavaScript, and you have to write the function, the multiply function, with recursion, using the recursive method. Okay, so normally if you write a function for multiply with the input x and y, and you will get a product of the two numbers, you will just write return x times y. And you're done without recursion. But we're gonna use recursive way. So yeah, no multiplying operation is allowed. So from the first video, what is the first step in the recursion method? Right? What's the first thing you want to figure out on recursion? Yes, the base case. What is our base case in multiplication? So let's assume that our base case could be, something like some number times 0. Let's try that out. If, let's say one of this number, x and y, is 0. Let's say I like y being 0. Let's do that. If y is 0, what do you return in this case? If y is 0, anything times 0 is, surprise, 0. You return 0. So now we know our base case. Let's figure out our next step, which is to figure out the recursive case, right? What is the recursive case? The recursive case is something we want to call the function itself within the body of the function and with a different input, right? So we know the base case if y is equal to 0, that's our base case. What if y is equal to 1, right? If y is equal to 1, let's say x is equal to 3. We should return 3 for the multiplication function. Alright, so we will return x. Okay? And what's return x? We will return 3. But we also want to add something to it. We want to add the multiply with x and y minus 1. Okay? You are trying to, using the recursive function right here, and try to solve the same problem with a smaller subset, right? Originally y is 1. We want to shrink it to reach the base case where y is equal to 0, right? Do you see what is happening here? So your x is always the same, right? But every time you call the function recursively, you are trying to solve a smaller problem in the recursive function. That's why we would decrement y by 1. Right, so let's say y is equal to 1 and x is equal to 3. In this case, this function is falsy. We don't return 0 here, right? We go to this line. We return x, which is 3, plus the recursive function multiply 3 and 0. And we know that this function, it turns out to be 0 because we know that if y is equal to 0, you return 0. So it's 3 plus 0, which is equal to 3. Fantastic. So let's go do another function, another input that is not 1. Like y is equal to like 4, like that. Maybe something not 1. Alright, let's look at another example. Y is equal to, let's say, 3. And then x is equal to 2. Okay? So let's go back to the concept of the call stack, right? What the call stack is? If you don't remember, go to the first video. Okay, so now we're going to solve this. Multiply, so let's say m2 and 3. Sorry. 2 and 3. Okay. What's it going to return us? It's going to return us 2 plus m2 to the 2, right? Because we're returning y minus 1 with x right here, right? This is x, this is y minus 1. So 3 minus 1 is equal to 2. Put it here. Okay, so now this call stack, this guy is waiting. This guy is waiting on the second layer, or second call of the recursive function. Alright? We know what 2 is, but we don't know what the multiplication for 2 and 2 is, right? So this guy is going to wait. And this guy is going to return 2 plus multiplication of 2 and 1. Alright? So this is another recursive call into the same function. And now this guy is going to wait. And it's going to return us 2 plus multiply of 2 and 0. Right? How do I got 0? Because 1 minus 1 equals 0. This is y. This is y. Right? So this gives us 0. Right? So this guy is done. This guy's done. It's pretty much 0. So 2 plus 0 equal to 2. We go to here. This guy is done waiting. So this guy is evaluated to 2. Okay? And this 2 in this line right here, 2 plus 2 is equal to 4. So this guy is done. He's done waiting. This evaluated to 4. Okay? And then you would say 2 plus 4 is 6. This line is done. This line is no longer waiting. So it turns out 2 plus 4 is equal to 6. So does that give us the right answer for 2 multiplied by 3? 2 times 3 is 6. So that's exactly what we got from our recursive function. So in this episode, with Recursion Lesson 2, I want to talk about something called edge cases. And edge cases not only apply to recursion functions, it could apply to any function that you can think about. Like if you try to solve a problem that the input is really minimal or rare, then you have this edge case that might trigger a different result than you would expect. So in our last implementation of the multiplication, we have the base case, and then we have the recursive case. But what could be our edge case, right? So we only test the number, the input that we have in the previous implementation is the positive integers or any positive numbers and zeros. What if the input is a negative number? What we just did would not work, right? But if we take care of the edge case, So the edge case in this scenario is the negative input. And now we're going to look at how we're going to solve this problem with the edge case in mind. Let's begin with our previous implementation. So I kind of optimize it a little bit, because in here I say if x or y is equal to 0, which is between 0. So if any x or y is 0, then just boom, that's our base case. So and then we take care of the edge case right now, right? So we have a condition right here. If y is greater than 0, that's what we had before. And then we return the same thing, right? So we return x plus multiply x, and then y minus 1, right? Y minus 1 because we want to go toward, the y should go towards 0, because if y is greater than 1, then you want to decrement y to go to 0. What if else? In the else statement, that means the y is less than 0, right? Y could be negative 1, negative 2, right? So in order to get us try to solve the problem towards 0, you want to add 1 to it, okay? Let's look at this example here. Let's say we have x equal to 3 and y is equal to negative 1. What do you expect to return in this case, right? If x is 3 and y is negative 1, we should return negative 3, right? So we'll return a negative x. Check this out, a negative x plus the multiply of x and y plus 1. And you know how that works? Right, so y plus 1, like I said before, because we want to get this second parameter towards 0 to our base case, right? And we return negative x because it will be a negative number. So in this case, if x is 3 and y is negative 1, you return this evaluates to negative 3, right? Plus multiply 3 x plus 1 now, y plus 1, negative 1 plus 1 is 0. So this evaluates to 0. So now you have negative 3. Let's check it out if it works. If y is negative 2, let's say. Okay, so let's look at this example with the multiplication for 3 as x and negative 2 as y. Okay, so now we're gonna look at this one, and then what does it evaluate to? We don't know, because that for this case, if this is x, this is y, y is less than 0, so it's a negative number. So we will go to the else statement right here. Right? We'll return. This is the return symbol, by the way. we'll return negative x, which is negative 3, plus. It's M for short for multiply in this function, okay? So this is save them space. So it's negative 3 plus multiply by 3 and y plus 1. Y is negative 2, negative plus 1 is negative 1. Okay? Then we return this, and this function is waiting. Now on the second level, on the second recursive call, this function is waiting. And that's what this return is negative 3, alright, plus multiply 3 and 0. And this evaluates to 0 because one of number is 0, right? 0. So now this function used to be waiting. Once it evaluates to 0, this is no longer waiting. Alright, so this is 0. 0. And then you have negative 3 plus 0, which is negative 3. Right? This is done. This is negative 3. Right? This is no longer waiting. Now you have the second call is going to be solved now. Okay? Negative 3 plus negative 3 is equal to 6, negative 6. This thing is done. And this returns to here. This is no longer waiting. Okay, so now you have multiple 3 as x and the negative as y, you should return negative 6. And that's the expected answer. And if you want to be fancy with the ternary operation, you just return, if y is greater than 0, you will return x plus multiply x and y minus 1. Else, negative x plus multiply x, y plus 1. Alright, for another edge case, we have x is equal to a negative number. Okay, for some of you have trust issues with me. Okay, so now let's say we have a cos that with alpha already. So we have negative 2 as x and negative 2 as y. And then this function, it will return negative 2 plus the recursive function of negative 2 and negative 1, right? Because negative 2 plus 1, y plus 1 is negative 1. And this function will be waiting at this point for this to be evaluated. So this will return negative 2 plus the multiply of 2, negative 2, and 0. And this is waiting now. Alright? And this will return 0. Okay? This will return negative 2. Cross this out. And on this level, this one is no longer waiting. So this one is negative 2, negative 2 plus negative 2 is evaluates to negative 4. Okay? And this is no longer waiting. Alright? So multiply of negative 2 and negative 2 is 4. So let's summarize what we did today. Today we're gonna summarize what we're gonna do today. So let's summarize what we did today. Today, what? You shake the camera, dude. Don't kick the stand. So let's summarize what we did today. Today we implement the multiplication function with recursive methods. Alright? We found the base case for the recursion. We found a recursive case for the recursion. And we take care of some edge cases. So edge case is very important in any kind of functions, right? So you make sure you take care of those inputs as well. And then another concept I want to emphasize is that every time when you try to call the recursive function, you want to go towards that base case, right? Our base case is when one of a number is 0 in our case. And then you want to, if your number is bigger than 0, let's say it's 1, you want the next recursive number, you want to like 1 minus 1. So it goes towards the base case, right? That's exactly what we did there, right? We have y equal to either minus 1 or y is plus 1 for negative numbers. So we always want to go towards the base case on every recursive call we do. Okay? Alright, so this is it for recursive lesson 2. Stay tuned for lesson 3. I think many people accuse me for why are you not doing Fibonacci number for recursive lessons. I'm like, okay, you'll get that next time. You'll get that Fibonacci number. Alright everybody, thank you for watching. If you found this video to be informative and be useful to you, please like the video, subscribe to our channel, and I'll see you next time. Keep on coding!